Today we're looking at Chapter 4, Lesson 5, Scatter Plots and Lines of Fit. So previously we were writing equations given a point and the slope, or 2 points. Today we're looking at relationships between the quantities using the points. We're also going to create lines of fit and write equations based on those to help us make predictions and such. So we've worked with equations with two variables before. Well, today we're going to name them and call them bivariate data. So data with two variables. We'll be putting that data on scatter plots. So scatter plots show a relationship. One scatter plot would show the relationship between the data, and it's always a graph of coordinate pairs. Alright, next thing is a line of fit, or you might hear line of best fit. So on a scatter plot, a line of best fit would also be called a trend line. So those are synonyms. You might hear either one. We're also going to do some linear interpolation and extrapolation today. So interpolation means predicting values inside a range of data. So let's say you're given 2 points on a line. You want to find a point in between those. You could use your equation to help you figure that out. We've already done it. Again, today we're naming it, but you've already done that before. So if you see points on a scatter plot, we see that these kind of go upwards. This means that it's a positive correlation. These go downwards, so it's negative. There may be times when there is no correlation and you would say that. I don't really see a trend going on, so no correlation. How about this part here? So this is a good example to start off with. It says the graph shows the average number of students per computer in Maria's school. Determine whether the graph shows a positive correlation, negative correlation, or no correlation. And then it says if there's positive or negative, describe its meaning. Okay. Clearly looks negative to me. It's a downward trend. What does it mean? Well, students per computer and then years. So it looks like a long time ago, in 2000, there was a whole bunch of kids on one computer, and now it looks like, students per computer. So there's 40 kids on one computer, or who had to share one computer perhaps throughout the day. And now it looks like there's a lot less. So I would say something like that. A negative trend, each year more computers are in the school, making the students per computer ratio smaller. Okay? So this sentence is more of an interpreting what it means. It's not necessarily just saying downward trend. Well, yeah, we know it's a downward trend, but what does it mean? All right, you try. So pause right here, see what you can do. When I work through it, it says here the graph shows the number of mail-order prescriptions. Determine whether the graph shows a positive, or negative, or no correlation. If it's positive or negative, describe it. This looks pretty positive. It looks like a line to me. So how could we interpret this? This says here positive with each year number of prescriptions has increased. Number of mail-order prescriptions has increased. All right? So overall, your job in this section, make it I guess this would say likely for your homework. This would be what's required. Make a scatter plot. Determine if there's a relationship. Draw a line that seems to pass close to most of the data points. That's your line of best fit. Use 2 points on the line to write an equation, and then use the line to make predictions. So let's do some more of that. So this is saying the table shows the world population growing at a pretty rapid rate. Identify the independent and dependent variables, make a scatter plot, and determine what relationship exists, if any. So first thing was identify the variables. This says independent variable is the year, dependent is the population. That makes sense. As the years increase, the population increases. There's a positive correlation because the question was asking us, make a scatter plot and determine what relationship, if any, exists. So to make the scatter plot, you would go this would be your first coordinate pair. So you would draw that out, 1650, 500. And then 1850, 1000. So those are the points that you would put on your graph. So you would go over to 1650 and then up to 500. That's where your point would go. Next, over to 1850, up to 1000, and so on your graph. So that's how they built this. Be sure your graphs are large enough that I can see it, and be sure it goes by even intervals on the bottom and even intervals here. Please make sure you add numbers. Don't expect me to guess. If I have to guess, I'm marking it wrong and saying it's not there, okay? So be sure that you add numbers on your x and y axis, x and y axis. Make sure they're even, and make sure you carefully plot your points. I know graphs take a while, but come on. Make sure they're good graphs. Okay. So then it says here, as the years increase, the population increases. That makes sense. And it says there is a positive correlation between these two variables. So we're saying, I would bet that the population is going to increase. Yeah, we just say positive correlation. As one goes up, so does the other. Let's see. I think it was asking us next to write an equation, right? Draw a line of fit. So it doesn't look like one line would hit all the points. Yours might be, you could sketch this maybe like this, something like that. But no matter what, we're not going to hit them all. So do the best you can to hit as many as you can. It says no one line will pass through all of them, so do the best you can. Now we're going to do slope-intercept form of an equation for the line. So choose 2 points that are on the line. They might be points that you plotted, they might not be. But pick 2 points that are on the line. From that, find your slope. Feel free to pause if you want to look through this a little bit more, but I'm going to move on since we've already talked about slope. Once you have your slope, it says point slope form or slope-intercept form, either way. And eventually we're going to get it into slope-intercept form. That's typical, that's most familiar for us. So you can use any other point on the line to plug in the y1 and the x1 values so that you can get that into point or slope-intercept form. So now you try. Pause right here, see what you can do. I'm going to move on and let's see. Table shows the number of bachelor's degrees received since 1988. Draw a scatter plot and determine what relationship exists. It looks like a positive correlation. It says determine the relationship. I think that's it. So now it says draw a line of best fit for the scatter plot. So pause right here, see if you can draw a line of best fit for this scatter plot. All right? Pause right here, see what you can do. I chose this one. I thought this matched up with the data the best, so let me know if you have questions. The next one says write the slope-intercept form of an equation for the line of best fit. Pause right here, see what you can do, and actually I'm going to scroll back. So we're going to do slope-intercept form of this equation. So pause and see what you can do. When I worked through it, I got something close to this. So I was using point slope form or y-intercept form. I chose to do y-intercept form, but I did need to find my slope. So I'm choosing 2 points that are on the graph, 0 and to me it looked like 1100. I know it's hard to see, guys, so feel free to pause and zoom in if you need to. I'm not sure. This to me looked like it was at 1100, and then I chose to use this spot right here. Can you see? Oh, that's kind of hard. I thought that this at the equation, at the intersection of these lines, to me it looked like it was right on the intersection. So I chose that point right here, which ended up being 6 and 1150. So that's why I did this, 6, 1150, and it looked like 0 was at this number. So based on this, I did my slope, and when I did y2 minus y1, x2 minus x1, I got 8.3, and then the intercept would have been 1100. So I put in 8.3 and 1100, and that gave me something really close to this one. I know it's not negative. I know that's not my y-intercept. And that looked too far off. That wasn't really what I had. So I chose this one because it was closest. Let me know if you have questions. So now it's saying, here's another one that we're going to use, interpolation or extrapolation. So this says the table shows the world population growing at a rapid rate. Use the equation to predict the world's population in 2025. Okay, 2025. So we're going to, let's see here, use this equation and plug in 2025 for x, right? That's what they did, and they solved. You try. Pause right here, see what you can do. Oh, I guess it's not asking you to do anything yet. Hold on. Table and graph shows the number. Now it says use this equation to predict the number of bachelor's degrees that will be received in 2015. Now pause right here, see what you can do. Okay, I'm going to show you my work for it. So I said, well, 2015, we're saying years since 1988, so that's 27 years, right? So I plugged in 27 here, and then when I used that equation that they gave us, when I plugged it in, I got this number, 1,320. But it says this is the number in thousands, so that would actually be this number, right? Add 3 zeros to it. So my answer is A. Okay. Let me know if you have questions. That would be interpolation. So nice job, guys, with the interpolation. Here is the homework for this section, 4-5, page 250. There are not very many questions because they do take a while because we're talking about graphing and such. There's multiple questions with multiple parts. So good luck, and please reach out to me if you have questions. Email me or join our online office hours for extra help.